Hi, Year 7, and welcome to the last lesson of this week. Now, this is probably the hardest lesson of the week, writing a conclusion and an evaluation. This is a really difficult skill, but it's a really important skill for the scientific method. And so I'm going to try and walk you through how you can write a conclusion and then how you can evaluate your experiments that you've done this week. The key kind of terms today are reproducible and repeatable, analysis, analyzers, hypothesis, and hypotheses. We're going to be writing our conclusion using these four main steps. Describe. So we're describing the effect of the variables. So as we change the independent variable, how does the dependent variable change? We're only writing down what we can see. We're not explaining. So as we change the lubricant, the time it took for the object to slide down the ramp was what? Okay, that's what that should be. Your first kind of sentence or sentences should just be describing the effect of the variables. So, I don't know, as you change the lubricant to oil, the time it took the object to slide down the ramp decreased. Okay, you've just described the effect of that variable. Okay, how that independent variable has changed the dependent variable. So that's your first sentence or sentences in your conclusion. Your second one is explaining the results using scientific terms. So, because, why did those lubricants decrease the time it took for the object to slide down the ramp? So that really key word of friction comes in. And if you look at my first slide of my first PowerPoint this week, you'll see that picture of those two surfaces rubbing, because friction is two surfaces rubbing, okay? And lubrication, what that does is that means that the surfaces don't rub as much, okay? That our objects are able to slide over each other with less force. So in this one, when you're explaining your results, you're explaining why that lubricant worked best. Okay, using those scientific terms, so force, lubrication. Okay. You're also then going to mention if you had any anomalies, so results that didn't fit the pattern. Okay, so for example, if you got 5 seconds for all your results and then one of your results is 9 seconds, that's an anomaly. Okay, it doesn't fit the pattern, so you should have tested it again, but you also mention it in your conclusion. So you're going to mention this anomaly. And then lastly, you're going to go back and answer the question in the aim. So we'll look at that on the next slide. So describing the effect of the variables as what? So you write the independent variable changed, and then you write the dependent variable here, increased, decreased, or stayed the same. Okay, we just talked through that. All right, so as I change the lubricant to oil, the time it took for the object to slide down the ramp decreased. Okay, right there. Boom. Explain the results. This is because velocity, frequency, time, friction, force. Okay, all of those key words for your explaining your results, your next few sentences. Never use the word it. It's a big hint here. So as the area increases, it increases, or as the lubricant changed, it sped up. Okay, not it sped up, the object increased its speed. Okay, never use it. Use objects or specific words or what changed, not it. Note any anomalies. And then also have a go at trying to say why you might have got an anomaly. So you might have just been slow to start and stop the stopwatch, or you might not have spread the lubricant evenly on the surface, or It might have got caught because the surface was uneven. All right, try and have a think about what reasons you might have got those outliers. And then look back at the aim, which was to find out what the best lubricant is. So if you answered the question, did you work out in your experiment what the best lubricant was? Hopefully. And so hopefully you've then answered your aim. All right, last part of it, go, the best lubricant was therefore ... Okay, and that is your conclusion completed. Okay, now we get on to evaluation. How well have I done? Can I use the variables to describe the results? Oh, sorry, before we get on to evaluation, we can just have a conclusion checklist, okay? Make sure that we've done all of these things. So have a look at this list once you've finished writing your conclusion. Can you tick off and say you've done all of these different things? If you can, well done. If not, go back, add them in, okay? It's not too late. Right, we're now going to go on to evaluating the success of the experiment and suggesting improvements. This is a really important part of the scientific process because at the end of the day, the experiment might not have been perfect, might not have given you good results, but that is still usable. We can learn from our mistakes, and when we come to do it again, we can do better because we've evaluated our experiment and we know how to improve on it. So, evaluating your method. We need to think about all the steps in our method. So, did you control all of the variables? Did you make sure that they were all the same? Did you make sure your ramp was the same height? Did you make sure you spread the lubricant evenly? Did you make sure that you used the same object, the same equipment? Did you make sure you started and stopped the timer at the same time? Did you make sure that you tried to minimize the error by making sure that the object had the same surface area touching the ramp? You need to evaluate your method and say, this was not correct, for example. Our ramps varied slightly during the experiment, or the surface area of the object varied slightly, or the spread of the lubricant varied slightly, or was not correct. Okay, or it was difficult to stop the stopwatch fast enough because the times were too short. Okay, have a think about what went wrong in your experiment and write that down. All right, and then write down how could you improve it. What could you do next time? If it was too difficult to stop your stopwatch fast enough, one improvement might be to use a longer ramp so that your object is traveling longer. Okay, it might be to lower the ramp a little bit so your object moves slower. Okay, it might be to take more readings and then get an average from more readings. All right, have a think about how, if you were to do that experiment again next week, how would you improve on it? How would you make that experiment better? And now, last but not least, we're going to evaluate our data. Do you have confidence in your results? So firstly, do you think you had enough data? Do you think 3 tests was enough to get an average? Were there many outliers? Did you have lots of anomalies or only a few anomalies? Is there a big spread in your data? Did, for example, one test you get 2 seconds, one test you get 5 seconds, and one test you get 7 seconds? Okay, did that mean that it was difficult calculating the averages because there was a big spread? Is there a systematic error? Did you start and stop the timer at the wrong time every time? Okay, did you start for one experiment your object in front of the line at the start, and then for a different experiment with a different lubricant, did you then start with your object behind the line? Okay, have a think were there any errors in your data? Is there anything you're not really happy with? Okay, have a think and write down whether you think your results were really good or whether you could have improved. Okay. Hopefully that's the end of this lesson. I hope you've enjoyed it. Now next week we'll jump in a little bit more into these two terms, repeatable and reproducible. Alright, whether your measurements are very similar when repeated by the same group, and reproducible, so when they're repeated with a different person. Okay? I hope you've enjoyed this lesson and this week's lessons and doing the experiments. Next week we'll be doing the same thing. We'll be doing an experiment investigation. As always, take care, stay safe, and make sure to submit this investigation, alright? So we can pick the best few and give you guys some house points, because the competition is very close.